Well, you know, most people are scared of spiders, but actually spiders are really cool and unique animals. And spiders are a lot like you and I. They need to build a house, they need to eat, they need to survive and reproduce. My name is Christopher Holmes, and I'm a graduate student at the University of Illinois, and I'm an aquatic ecologist. I think the way spiders acquire resources are truly unique and cool. And so the analogy I like to use is spiders are like humans, and fishermen specifically. You go out to a lake, you need to catch fish to bring home to your family. If you throw out your net and you don't bring home any fish, your family doesn't eat. The same is the case for a spider. You spend all this time and energy building a web in order to catch flying insects to feed yourself and your offspring. And so the location of where you place your web is very important to your success as a spider. Spiders don't live in the water by any means, but actually the water is incredibly important for them because that's where their primary source of food comes from. And so many of these insects that are flying around in the sky, a lot of them have aquatic life stages, and so many of them will lay their eggs in the water, either in temporary ponds or lakes or streams, and then those larvae will develop and emerge from the water. And so once those flying insects emerge, there are the spider webs to catch them. So that's a strategy that many spiders have employed, are building webs nearby water or streams. Riffles are these fast-moving habitats in streams where the water is moving fast, allowing for rapid oxygenation of the water and also bringing food resources from upstream downstream, allowing many filter-feeding aquatic insects and aquatic invertebrates to acquire food there. Many studies have shown that there's more insect productivity. So in other words, there are more insects in these riffle habitats as opposed to non-riffled habitats. So if you're a spider, you put a lot of time and energy into where you build your web. And so if you're a spider, you want to put it in a spot where there are a lot of insects. But how does a spider know where exactly to put its web? I think that's the interesting question. So not only do we want to know, are there more spider webs nearby these riffle habitats, but are webs larger in areas where there are not riffles? Because if you think about it from the perspective of the spider, you need to acquire food. And so in these less productive areas where there are less insects, you might want to build a larger web in order to catch more insects. So we as a research group went out to a local stream and we looked at spider abundance and also the shape and size of their webs in these banks alongside riffle and non-riffle habitats. So to test the effects of riffle and non-riffle habitats on spider abundance and spiderweb morphology, we set up plots alongside a stream. And in those plots we searched for spiderwebs, but spiderwebs can be hard to see and measure. So we sprinkled regular baking flour on them just to make them more visible. And then we measured the web and identified what type of spider the web belongs to. And finally, with all that data we collected, we compared spider abundance and spider diversity between our riffle and non-riffle habitats. We didn't get the result we expected. We found that there was no difference in spiderweb abundance or diversity between riffle and non-riffle habitats. But science is a process, and for me, it's that process that keeps me excited and engaged.